One of the application of F distribution is when we compare two populations' standard deviations. To find the critical values for F distribution, we need to, of course, have two samples. So N1 and N2 will be the sample size for these two samples. And we need to have a significance level alpha. Now, the numerator degrees of freedom is referred to the degrees of freedom for the sample size 1, which is N1, and the denominator degrees of freedom will be for degrees of freedom for the sample size 2, which is N2. Now, the numerator degrees of freedom is always N1 minus 1, and the denominator degrees of freedom is N2 minus 1. And the area of each tail will be half of the significance level. So if we have a significance level alpha, then the area of each tail will be alpha over 2. Just like other distributions, we have a critical value right, which we're going to refer to that as FR, and we have a critical value on the left side, which we call it FL. So let's look at the example. For 95% confidence level with N1 equal to 12 and N2 equal to 8, we want to find the two critical values FR and FL. First, we establish our curve, which begins with 0 and skewed to the right, is very similar to chi distribution. Since N1 is equal to 12, the numerator degrees of freedom will be 11, and N2 equal to 8, the denominator degrees of freedom will be 7. With the 95% confidence level, that gives us a right tail area of 0.025 and the left tail area of 0.025. To find FR, we use program fval, and then we enter the right tail area of 0.025, the numerator degrees of freedom 11, and the denominator degrees of freedom 7. The calculator should give us a result of 4.709. We always keep 3 decimal places for these critical values. Now, for finding the left critical value, FL, first, we need to switch the degrees of freedom. So that means now the numerator degrees of freedom is 7, and the denominator degrees of freedom is 11. We run the program fval, just like we did. And whatever the answer is, we take the reciprocal of it by using the key that has x to the negative 1, which is directly above x to the second power. Once the answer appears, we take the, we press enter, and the answer for that should be 0.266. The left critical value in F distribution is always going to be less than 1. So again, we switch the degrees of freedom, we run the program fval, we take the reciprocal of the answer by using the x to the negative 1 key followed by enter, and in this case we get the left critical value of 0.266. Let's look at another one. We're supposed to find the critical value F for a right tail test with alpha significance level of 0.05 and sample size 1, 10, and sample size 2, 5. So N1 is equal to 10. That means the numerator degrees of freedom will be 9, 1 less than the sample size. And N2 is equal to 5. So the denominator degrees of freedom will be 4, N2 minus 1. We use the program fval. There is no need here to divide alpha by 2 because we're doing a right tail test. So we're using right tail area of 0.05 with the appropriate, numerator degrees of freedom, which we just found, we get the answer, which is 5.999. Again, for these critical values, we keep our answers to 3 decimal places. Let's look at another example. We want to find the critical value f for a left tail test with alpha equal to 2.02, n1 equal to 8, and n2 equal to 15. Since this is a left tail test, we need to switch the degrees of freedom. So our numerator degrees of freedom will be 15 minus 1, which is 14, and the denominator degrees of freedom will be 8 minus 1, which is 7. Again, we're going to use the program fval, and the area of the right tail will be 0.02, equal to the significance level. But since this is a left tail test, we have to take the reciprocal of the answer. And again, we can do that by pressing x to the -1 followed by enter. In this case, we get 0.201. I hope this presentation helps you to find critical values for F distribution.